Everyone, welcome to lesson 5 of CSEC Chemistry at Edu Solutions Institute. Now today's lesson will be a quick lesson on the periodic table. So last week we looked at the atomic structure, which tells us that elements are made up of atoms and they are structured differently based on the amount of electrons they have or the amount of protons they have in their nucleus or electrons that they have on their shells. Now, the periodic table, as you can see here, is just a unique arrangement of elements in terms of different properties or different appearances of these elements. Now, as you can see, this periodic table has columns, right? And they have different rows. Now, the columns are collectively called groups. So the periodic table is arranged in two ways, groups and periods. The columns are the groups and the periods are the rows. Now, it's unique because why do these elements arrange in this fashion? Why is hydrogen here and helium here? Why hydrogen was not over here and helium over here? And why is hydrogen here and not helium beside it or below it? So it's very important to know why these elements are put into their different groups as well as their different periods. So they're based in their groups based on how much valence electrons they have. Valence electron is how much electrons on their outer shell, the last shell. So remember last week when we drew our structures, we look at the different shells. The last shell that is drawn, how much electron is on that shell. And then we look at our periods. They are grouping their periods based on how much shells were drawn, right? So for elements, for hydrogen, we know that hydrogen is represented by 1, 1, which means in its nucleus it only has one proton and it only has one shell with one electron on it, right? But if we look at helium that's over here, helium is 2, 4. That means in its nucleus it has 2 protons, 2 neutrons, and then on its one shell, the first shell can hold 2 electrons. It will have its 2 electrons there. So we notice that they're in 2 different groups. Why? Because this has 1 electron on its outer shell. This has 2 electrons on its outer shell. Now, so that's why they're in 2 different groups. Now, why isn't helium in group 2? Because as you can see, the groups range from group 1, 2, 3, 4, right over to group 18, because we have 18 groups here. Now, at this CSEC level, we ignore group 3 to 12, because these are transitional elements. They work a little different sometimes, especially in their reaction. So we leave that for advanced levels of chemistry. So we'll only focus on group 1, group 2, group 13, 14, 15, 16, 17, and 18, right? Now, the reason why hydrogen is in group 1 and helium is not in group 2, even though it has 2 electrons on its outer shell, it's in group 18, is because group 18 elements are what we call noble gases or inert gases, which means they are lazy. They don't want to be involved in reactions. So because they're inert, they don't partake in a lot of reactions. So hence, their shell tells us a little about them. So the final shell tells that they already have the maximum they can have. So therefore, there is no need to go and get or to give or to share in order for them to be stable. And we look at that next week, especially for the stability of atoms. Now, because it's already full, because the first shell can only hold 2, we have to put helium in group 18, right? So it's a stable. It doesn't need to do anything. It's perfect by itself in terms of its reactivity, right? Now, hydrogen has 1, so it's in group 1. Now, if you go across the period, they are both in period 1. Why? Because we only have 1 shell for them. Right? Now, if you look at any other element, if you look at sodium, that's also in group 1. Right? So sodium Na 1123, that means it has 11 protons and 12 neutrons. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then final one shell, which has a 1 electron there. So it's still in group 1, right? And it's because it's in group 1, it has 1 electron on its outer shell. Now, if you look at the period that it's in, it's 1, 2, 3 shells. If you look on the periodic table, it will be in period 3. So now you notice that elements are placed in groups based on how much electrons they have on their outer shell, and they're placed in periods based on how much shells that they have. Now, why is elements beside each other now? They are beside each other based on their number. So if you notice, sodium is in group 1, and then right beside it in group 2, we have magnesium. And magnesium is 12, 24, 12, 11. So what we see here is that elements are arranged based on their atomic number. So going from left to right, they are in atomic number order. So it's hydrogen 1, helium 2, then we come down with element 3. Alright, and then we go across. When we finish across, we come back to group 1 and we continue that trek. So therefore, sodium is 11. It will be beside magnesium, which is 12. Now remember, there is a gap here that we're not focusing on. So therefore, we skip this gap and we go over to group 13, which is aluminum, which is actually 13 as well in its atomic number. Right? So we see here that elements are arranged from left to right in terms of their atomic number. They are arranged coming down in their groups because they have the same number of electrons on their outer shell, but also they will increase in shell amount going down. So hydrogen, 1 shell, right? Then the next element under will have 2 shells, right, which is lithium. And then next one will have 3 shells, which is sodium. So coming down the group, they have the same amount of electrons on their shells, but they have increased 1 more shell each time, right? And then going across in your period, you have the same amount of shell, but from left to right, your electrons in their shell will increase. So in period 1, it goes from 1, then the next element is helium, which is 2 electrons, but they still have 1 shell. Right? Now, finally, about the periodic table is that even though they're grouped into groups and periods, we have 3 main sections of the periodic table that we focus on. And these are the first 3 groups, which will include group 1, group 2, and group 13, which are called metals. Now, metals, they are metals because they have 1 to 3 electrons on their outer shell, right? Now, what they will do, next week we'll look at that, right? So, metals, group 1, 2, over to group 30. So, these are called metals. Now, there are also unique names of group 1 and 2 elements, right? So, group 1 elements are called alkali metals, and group 2 elements are called alkaline earth metals. Alright, so that's another way of saying group 1 or group 2. So again, group 1 to 13 are metals because on their outer shell they will have a 1 to 3 electrons on their outer shell. And then we have elements in between, slightly in between. If you notice on your periodic table, there is a little step here between group 4 and 5. Elements on that step are called semiconductors or semi-metals or metalloids, right? Because they can exhibit characteristics of metals as well as they will exhibit characteristics of the next group of elements, which are called non-metals. And non-metals range from group 15 over to group 18. And what this means is that they have 5 to 8 electrons on their outer shell. Now, because they are three different main areas of the periodic table, it tells us about their chemical properties as well as their physical appearances. Because metals have a shiny more appearance, right? They're harder, right? And they can be beaten into sheets, which is called malleability, or they can be stretched without breaking easily, which is called ductility, right? And then we have our non-metals, which these are more gases at room temperature, right? They are not that brightly colored like the metals. They are not easily stretched, right? So those that can be metals at room temperature, solids at room temperature, sorry, are not. If you stretch them too much, they will break, right? Or if you start beating them, they will start breaking up as well. So those are some of the distinguishing factors between your metals, your metalloids, and your non-metals. So next week we'll be looking at bonding. How are these different groups, different sections of the periodic table? How are they in terms of their chemical properties? So that's it for this week's lesson. Hope you guys have understood a little bit more about your periodic table, and I'll see you next week.